Open your cerebral cortex and shift your lobes into upper beta phase, because you are going to have Bitcoin knowledge transmitted directly into your vestibulocochlear. Your host at Bitcoin Knowledge is Trace Mayer, an early Bitcoin advocate since it cost $0.25, but this is not intended to be investment advice. A doctor of jurisprudence, but this is definitely not legal advice. And an investor in core cryptocurrency infrastructure, including Armory, BitPay, Kraken, and Mitagio, but this is not a recommendation of those services. Here, you get fed via direct mind download with pure and free Bitcoin knowledge.
Hi, my name is Jonas Schnelli. I'm a Bitcoin core developer, and I'm gonna focus today on hierarchical deterministic key generation. What is hierarchical deterministic key generation? Let's first have a look at traditional key generation. So what is actually a private key and a public key? A private key is basically a 32 bytes random number, which then can be used over elliptic curve cryptography to generate a public key. And this is a one-way function, or let's say you can only reverse the function by solving the discrete logarithmic problem, which is kind of unsolvable. So when you have a public key, you cannot generate its private key from the public key, but you can generate the public key from the private key. And the public key will be used to receive funds. You can say it's your Bitcoin address. And the private key, that needs to be stored safe somewhere in your wallet, and it needs to be used to sign a transaction that spans these funds you have received with the according public key. Now, that's the way how Bitcoin works under the hood. The problem is when you do backups. First, when you create a key, you need to do the backup after you have created the key. Because let's assume you generate a new receiving address after you have created a backup. That means the new private key is not covered in that backup. So you need to do a backup after each key you have created, or you have to use something that is called key pools. But in general, it makes backups more difficult. So that's why some years ago, clever engineers came up with a solution called hierarchical deterministic key generation. That allows you basically to have extended private keys and extended public keys. What can you do with that? It's actually a scheme where you have one master private key. That master private key can be used to derive all the child keys. Whenever you generate a new child key, you can always recreate it via your master private key. So as long as you keep your master private key safe somewhere in a backup file or on the hardware wallet, you can always regenerate all your receiving addresses and the according private keys to spend the funds you have received with these addresses. So then what is an extended public or an extended private key? It's a standard private or public key with additional information that allows you to create a chain or a hierarchy chain of keys. Once you have a master private key, you can derive a child private key out of it. And that is always in a hierarchical level. You can say your master key is M, master, and then you can generate M/1, which means it's the second sub-key of your master key. And that has endless depths, so you can generate master/0/1 to generate any type of hierarchy. So what can you do with that? You can, if you have a company with several branches, as an example, you can generate a master key for your overall company funds. And then you hand out master/0 to your first branch and master/1 one to your second branch. So then they have an independent chain of keys. So they can generate endless amounts of sub-branches or receiving addresses. And you can, by controlling the master key, you can always regenerate both branches' funds or both branches' public and private keys. But they can't see the other branch. So branch B cannot see funds of branch A because they only have master/1. And on top of that, you also can do a nice thing that's called public key derivation. You could hand out, let's assume branch C, you can hand out them just an extended public key. So what means handing out an extended public key? That means they only can derive public keys from that extended public key. They never can derive a private key out of it. So they will never be capable of spending funds, only receiving funds, creating addresses. So they can generate tons of receiving addresses. They can also do a hierarchical level of these addresses, but they never will be capable of spending these funds. That also gives a possibility of handing out an extended public key to somewhere where you actually have funds on these address levels. So when you hand out an extended public key of a branch in your hierarchy where you actually control coins, that would allow the user that receives that extended public key to generate addresses and watch your funds just as an audit. They can just watch what you're receiving, what you're doing with your private keys, but they don't have the capability of spending these funds. And also a very important concept then is multisig wallets. You can hand out someone an extended public key so that he can generate public keys out of your extended public key, child public keys. And these can be used to generate multisig addresses because then he can generate his public key and your public key, and that will allow you to generate the multisig address in that example, a 2 of 2. But what he not can do, he cannot sign the multisig transaction without having the according private key, and you handed only out the extended public key. So the multisig still requires your signature to make the transaction valid. And also handing out an extended public key can be used for payment processing. If you want to have a script on your web page to receive funds, you could place an extended public key somewhere in your script, and that script could generate endless amounts of receiving addresses, so you don't do address reuse. And the server or the script can never access funds because it's just the public key, the extended public key. So are there any risks involved with hierarchical deterministic key generation? In general, it's the same level of security when you generate child keys of an extended public key or an extended private key, like similar to generating an independent traditional key. But something needs to be taken care of. Extended public keys should really kept kind of private or only handed out to people you trust. Because if someone accesses or controls one of your extended public keys together with a child private key, which normally should not happen, but it can happen. So if you hand out an extended public key together with a sub-child key, a child private key, not an extended one, that can reveal the whole chain. And that can be dangerous. So handing out a private key should never be done. That's a general concept. And handing out a extended public key should be also be something you only do when it's necessary, like for a multisig wallet or for a payment processor. But even then, you should be really careful about it. And obviously, a high risk is keeping the master private keys safe, because that key kind of can recreate all sub private keys. So that needs to be stored really somewhere safe. So let's go a level deeper into the technical details of how hierarchical deterministic key generation works. So the only entropy required is the master private key. From that you use a hash function. For that we use HMAC SHA-512, which spits out the 64-byte hash. And the first 32 bytes will be used for the new key, for deriving the new key. The second 32 bytes will be used for the chain code. That chain code is an additional element to not only depend on the master private key's entropy. So then there's another concept of having two different types of extended keys. One is the hardnet extended key, and one is the traditional extended key. The hardnet extended key means it's the end in the hierarchy level. You cannot derive subkeys or child keys out of a hardnet public or private key. So whenever your application allows it, you should derive a hardnet child key for receiving funds or creating an address. Extended public and extended private keys also have its own serialization format. You might have seen that a hex byte array starting with xpriv or xpub. That is an serialized base 58 jack encoded extended public or extended private key. So you can use that encoding format to transport private or public keys to somewhere else. So conclusion, hierarchical deterministic key generation is probably the concept you should use nowadays. It has some nice benefits, but keep aware of the problem of revealing a private key together with an extended public key, and make sure you have a proper backup storage solution for your master private key. So then, thanks for listening.
Be sure to get a copy of the free Bitcoin Guide at freebitcoinguide.com. Got a question or suggestion? Record your voice at bitcoin.kn. Don't be shy. To help the show, share bitcoin.kn with friends, post about it on Reddit, and otherwise spam the interwebs. Your iTunes comments and 5-star reviews are very important to us. Please continue tuning in to the Bitcoin Knowledge Podcast, where we release interviews with the top people in the Bitcoin world. Now take some choline and let that Bitcoin knowledge consolidate.